Hello students, I hope that you are good, well and fine. Today we will be seeing what? The chapter 5 continuity and differentiability exercise NCERT exercise 5.7 solutions. Okay. So far and obviously this exercise, if you are following our sessions, this exercise is related to second order derivatives and we already covered the theory part for that also. Okay, now let's see, or let's jump to our first question of this exercise 5.7. So first question says that find the second order derivative of this x square plus 3x plus 2. So how you can find very easily. So first d by dx, you have to find d by dx for this thing. Okay, and this will be just 2x plus 3. Now what? Now again you have to find the derivative of this. So as you can see, finding the derivative for this will be, this will imply d2x by d, sorry, okay, this will be, let me just use eraser. So this will be d2 by dx square x square plus 3x plus 2. The second order derivative will be just what? Same as derivative of this, which will be derivative of this 2x plus 3, and which will be just 2. So your answer will be just 2. Okay, as you can see, your answer will be just 2. Okay, simple. Okay, now let us move to next question. Now derivate this. So derivation of, for the first time, of this x power 20 will be 20. Now reduce one power, it will be 19. Now the derivative for the second time will be dx square. Okay, clear? So it will be like this from x power 20. Okay, this will be what? Derivating this one more time, you will get 3, okay, 80x power 18. Yes, because 19 will be multiplying with 20, and 19 multiply 20 will give you what? 19 times 2 gives you 38. 38 10 will give you 380. So your final answer will be 380 multiply with x power 18, as you can see. Okay, 380 multiply with x power 18. Okay, clear? Okay, now let us move to next. So problem number 3. So problem 3 says, x cos x. Okay, no problem. So derivative, first time derivative, if you say that this is your y, okay, let me just equate it equals to y, let this is equals to y, then y prime will be cos x. Okay, cos x, okay, cos x minus x sin x. Okay, sin x, cos x minus x sin x. Now derivate once again, you will have y double derivate, this derivation will be minus sin x, so far so good, and this will be sin x, okay, plus x cos x, okay. Now just multiply with a sine, what you will have, just simplify it, your answer will be what? Let me just show you. You will have minus 2 sin x, as you can see, minus 2 sin x and minus x cos x. Taking x minus common, you will have 2 sin x, x cos x. You will have 2 sin x, x cos x, as written over here. If you take minus out, you will have x sin x plus 2 sin x, x cos x plus 2 sin x. Okay, simple. Okay, now fourth problem, derivate this twice. So if this is equals to y, then what you can do is y derivative is equals to 1 y derivative is equals to 1 by x. This will imply again y double derivative is equals to derivative of this. This means derivative of x power minus 1, and this will be minus 1 multiply with x power minus 1 minus 1. This means minus 1 divided by x square. Okay, so your answer for this will be minus 1 x square. Okay, now fifth problem. Now fifth problem says if you take this as y, then your y derivative will be y derivative. Okay, so y derivative will be what? So it will be 3x square log x, okay, plus with x cube. Now derivative of log x will be just x, so this will be just x square. Okay, this will be just x square. This will be just x square. Okay, you will have this. Now the second order derivative will be what? This will be, let me just derivate it first. So 2x now plus, now derivative of this part will be, so 3, okay, taking 3 common. Now derivative of the inside thing, you will have 2x log x plus x square divided by x. You will have just x, left x. You will have this. Okay, so your final answer will be of this form. As you can see, if you take things common and plus and minus, so this 3x and this 2x will give you 5x, and this will be 6x log x. So 5x, as you can see, 5x plus 6x log x. Take x common, you will have this form which is written over here, x multiply with 5 plus 6 log x. Okay, clear? Okay, now the sixth problem. Now sixth problem says this thing, quite simple. Take it equals to y. Now y first derivative will be just ex sine, ex. So let me just put this thing over here, or let me just put this thing over here. Okay, so ex sine, okay, sine 5x. Now plus this will be 5 ex cos x, cos 5x. Okay, cos 5x, cos 5x. Okay, and now again derivate it. What you will have, this will be what? Ex sine 5x plus 5ex cos 5x. Okay, now for this part, this will be plus 5 inside bracket. You will have ex cos 5x plus this will be ex 5 and minus sine 5x. So sine 5x, so minus, okay, minus 5. This will be 5. Now just simplify what you will have. As you can see, just very easy to see that 5ex cos 5x, and this will also be 5ex cos 5x. So this will become 10. Okay, and for this it will be 25ex sine 5x, and this will be ex 5x. So this will become minus 24. Okay, clear? So let me just show you what is happening. So as you can see, yes, so this will be 5 ex cos 5x, and here it will be minus 24 ex sine 5x. So taking 2ex common, you will have, okay, so as you can see, ex 10 ex cos 5x and minus 24 ex sine 5x. Taking 2 e power x, you will have this form. I hope that it is clear. Okay, let us move to next problem, problem number 7. So problem 7, take this as y. Now differentiate it. you will have y derivative is equals to 6e 6x cos 3x. Okay, now plus e6x. Okay, this will be what? Minus sine 3x multiply with 3. Okay, clear? Okay, so far so good. Now double derivative for this will be, okay, let me just show you the answer. Okay, so derivative will be what? Let's see. So first thing, I have already evaluated the first derivative. As you can see, 6 is e power 6x cos 3x. As you can see, 6 e power 6x cos 3x minus 3 e power 6x sin 3x. Okay, now the second derivative will be derivative of this part. Now the first part derivative will be 6 multiplied with derivative of this part and minus 3 multiplied with derivative of this part. You will have what? You will have this part will be 6e, as you can see, 6e power 6 cos 3x, 6e power 3 cos 3x. Now this will be minus e power or e power 6x multiply with minus sine 3x multiply with 3. So this is written over here in arranged form. Okay, now the for this, so minus 3 multiply with this derivative part. This will be derivative of e power 6x multiplying with sine 3x and plus derivative of sine 3x multiply with normal e power 6x. So you will have, after multiplying here, you will have 36 e power x cos 3x minus 18 e power x sin 3x minus, and this will be what? 6 e power 6x. So 6 e power 6x, and this will be what? 3 cos 3x. So 3 cos 3x. Now just multiply the terms. You will have this as your expanded form of, or the simplified form after multiplication. Now further simplification can be done. Add this 36 e power 6x cos x to what? This minus e power 6x cos 3x. You will get 27 e power 6x cos 3x. Now this minus and this minus will become minus 36 e power 6x sin 3x, and you can take e power 9 e power 6x common, and you only left with 3 cos 3x minus sin 3x. Okay, clear? Okay, so you will get your answer is this 9 e power 6x multiply with 3 cos 3x minus 4 sin 3x. Okay, this is your 7th problem. Now 8th problem. 8th problem is quite simple, I think. So first derivative of this will be 1 by 1 plus x square. Very easy. Now second derivative will be, if you try to use the concept of power, you will have minus here. Okay, you will have minus here, and 1 by 1 plus x square whole square. Okay, and in numerator you will have to multiply with the derivative of the denominator, which is just 2x. Okay, just 2x. Clear? Just 2x. So your final form for this will be this thing. Okay, let me just show you also. As you can see, minus 2x divided by 1 plus x square whole square. Simple, very easy to remember. So what we have used, the power rule. If you want to use the quotient rule, please do so. Okay, simple. Okay, and now the 9th problem, very easy. Y dash will be 1 by log x, and the derivative of now log x will be 1 by x. So you will have 1 by x log x. Okay, simple. Now what you have to do now, now derive it. Let me just show you. Use the quotient rule. Now you will use the quotient rule. So quotient rule says what? Okay, I hope that it is clear. or also you are here we are using the power rule in this form. So the first derivative is this. We can rearrange or rewritten this form as this x log x whole inverse. Now derivate this, you will get the second order derivative. So the second order derivative will be the same as the first order derivative of this form. You will have minus 1 x log x power minus 2. Now derivative of the inside thing, which is x log x, and this is just nothing but 1 plus log x. Okay, this is just nothing but 1 plus log x. The derivative of x log x will be, we have already evaluated it. So if you remember this, then it will be very beneficial for you so that you can directly use that. So whenever you see this, the derivative of this, the prime means the derivative of this is just nothing 1 plus log x. Okay, 1 plus log x. If you remember this, you can directly use it without any evaluation, further losing your time. So this will be what, minus 1 by x log x whole square multiply with 1 plus log x, as you can see. So your final answer will be minus, in numerator, minus 1 multiply with 1 plus log x divided by x log x whole square. Okay, simple. Okay, let us move to the problem number 10th. So problem 10 says sine log x. So let me just evaluate the first derivative. So first derivative will be log x derivative, which is x, multiply with sine derivative. Sine is cos. Now cos whatever the inside thing, which will be log x. Simple, easy. Now the second derivative, let me just show you for the second derivatives. So second derivative, as you can see, the first derivative we have evaluated it, which is just nothing but the what, cos log x. Okay, yes, cos log x divided by x. Okay, now the second derivative, the derivative of this we will use, now we will be using the quotient rule, which says that u by v, or let me just use different so you won't be confused, u p by r. Okay, so p by r derivative can be rewritten as r square. Okay, so p by r derivative is r square in denominator. In here r multiply with p derivative minus r derivative multiply with p. This is happening, that's it. Okay, simple. So we will use, so square of this, as you can see, now this multiply with this derivative, as you can see, x multiply with this derivative, now minus the numerator thing is now getting multiplied with the denominator derivative, like this. Denominator is x, just x. Now simplify it, it will be the derivative of cos x log x will be just 1 by x. Okay, this will be what I'm directly saying. Okay, you will see, you are the steps are in front of your eyes. So minus sine x minus sine log x by x. So minus sine log x by x. So x and x will be cancelled. You are only left with minus sine log x. Okay, so far so good. Now for this will be just 1. So you will have minus, if you take minus common, you only left with sine x log x plus cos x log x divided by x square. So your final answer or the second derivative of the given expression will be of this form. Okay, I hope it is clear to you. Let us move to next. Now 11th problem. 11th problem says this is y, then we have to prove. Here we have to prove. So first of all we have to find the double or second order derivative. So easy to find. So y okay, so let me just evaluate here. Y derivative is equals to just nothing minus 5 sine x minus 5 sine x and minus 3. Okay, minus, okay, let me use it here, minus 3. Okay, so let me just show you the answer. Okay, minus 3, as you can see, minus 5 sin x minus 3 cos x, you will have minus 5 sin x plus 3 cos x. Okay, now what? Now you got this. Now derivate once again, you will have a double derivative, so it will be minus is already outside. Okay, so it will be 5 cos x minus 3 sin x. So 5 cos x minus 3 sin x, as you can see, 5 cos x minus 3 sin x. So 5 cos x minus 3 sin x, this will be what? As you can see, if you see your expression, so what is your y is 5 cos x minus 3 sin x. So this is what written over here. So it will be d double derivative is equals to minus y. So I am taking this minus y to the left hand side, so you will have what? d2y by dx square plus y is equals to 0. So that's the thing we wanted. Okay, so hence we proved. Okay, simple. Okay, now the 12th problem. Now 12th problem says y is equals to cos inverse x. Then we have to find the double derivative, but in terms of y. Okay, no problem. So y derivative is equals to what? Minus 1 by root 1 minus x square. Okay, minus 1 by root 1 minus x square. That's what we have. Now what? Now you can do the same for d2y. So what you will have, as you can see, so for d2y you will have this, we will be applying power rule type. This means taking as minus half. Okay, clear? Okay, now what you will have, minus is already there. Now derivative of the inside thing will be minus of half the inside thing, which is 1 minus x square power minus 3 by 2. Now derivative of this inside thing, you will have minus 2x. Now solving everything, you will get this 2 as cancelled. You will left with minus x by root 1 minus x square whole cube. Okay, now what you have to do is that if you put x is equals to cos y, if you put x is equals to cos y, why I am saying that? As it is already written over here. Yes, at this step, what is it given? Y is equals to cos inverse x, and this means that cos y, this means cos y is just nothing x. Okay, cos y is just nothing x. That's why we can substitute this. Okay, so substitute x is equals to cos y. You will have minus cos y divided by root of 1 minus cos square y whole cube. This means minus cos y divided by sine square y cube. So this will be sine cube. As you can see, you will have your expression in this form, and this can be reduced. If you want to leave your answer here, yes, you can leave. Why? Because just question is just asking that please provide your answer in terms of y. You provided it. If you want simplify it more, then you can reduce it at minus cot multiply with cosec square. So minus cot multiply with cosec y, cosec square y. Okay, simple. Okay, let us move to the next problem. Problem number 13. Problem 13 says y is equals to 3 cos log x plus 4 sin log x. Then we have to show this y2. This y2 written over here means double derivative. This y1 means first derivative. Okay, don't confuse. So let me just quickly show you. So first derivative will be y1, y subscript 1 will be just nothing but minus 3 sin log x divided by x. As you can see, minus 3 sin log x divided by x. I am just directly saying, and this will be 4 cos log x divided by x, 4 cos log x divided by x. Okay, taking LCM same, okay, as x, you will have simplified this. Now y2 will be, now what I will be using, I will be using the quotient rule. So by quotient rule, it will be what? It will be as you can see, x square, the denominator square. Now denominator getting multiplied with this derivative of this, okay, and minus, as you can see, derivative we used here what, the prime sign, okay, and this numerator getting multiplied with the denominator derivative, as you can see the derivative here prime. Okay, now this will be just 1, so minus 4 cos log x minus 3 sin log x, you will get this. Okay, now, okay, so as you can see, okay, I hope so. Obviously we are taking this here, we have used the brackets, okay, brackets, so this will become, the minus is outside, so this will become, after distributing this minus sign, this will be minus 4 cos log x and it will become plus, as you can see, so don't confuse with signs. Now x multiplies this whole thing, so the derivative inside will give you minus 4 sin log x divided by x, and from here what you will have, minus 3 cos log x divided by x, okay, as you can see. So I'm just directly saying, I'm just directly jumping to this step, as you can see, minus 4 sin log x divided by x minus 3 cos log x divided by x. Okay, now what? Simple. Now just take LCM and just manipulate things. What you will have is this, okay, taking LCM you will have x multiply, taking LCM, take LCM, the x and x will be cancelled, you only left minus 4 sin log x minus 3 log cos log x minus 4 cos log x plus 3 sin log x, okay. This will give you what, as you can see, this will give you sine with sine will give you minus sin log x, and minus 3 minus 4 will give you minus 7 cos log x divided by x square. Okay, now put things, now y2 is this, now multiply y2 or the second order derivative with x square, you will get this x square and this x square will cancel. We are doing what, we are substituting in the expression we are given, okay, and try to show that expression equals to 0. Okay, now multiply with x with the first order derivative, so you will get x cancelled, and add what, y is just nothing, y is what, as you can see, y is 3 cos log x plus 4 sin log x. Now what you see, after cancellation you will have minus sin log x minus 7 log x plus 4 cos log x minus 3 log x plus 3 log x. If you try to see this 4 cos log x and this 3 cos log x will add up to 7 cos log x plus 7 cos log x, and here we are having minus 7 cos log x, so all these three terms will be cancelled. Now minus sin log x and minus 3 log x will give you minus 4 log x, and after getting minus 4 log x, if you try to see, you are having plus 4 sin log x, so this will also get cancelled, so you only left with 0. So you prove that the given y, the given function and the given expression, if you put the respective value, the corresponding value, you will get the answer as 0. So hence proved. Okay, clear? Okay. Now 14th problem, let me just quickly show you. So we have to prove that this thing gives you 0. So let me just quickly show you the solution. Y is given as a e power mx plus b e power nx. So derivating first time, I'm just directly saying that it will be a m e mx and b n e nx, as you can see. Okay, a m e nx and b n e nx. Okay, so here it is m. Okay, it is a m e m x. Okay, please correct this. Okay, now the second order derivative will be what? Very simple, so you have to derivate it. So it will be a m square e mx and b n square e nx. So a m square e mx and b n square. Okay, now what you have to do, now the second order derivative minus the given, we have to use this given expression and substitute the corresponding value. You will, this value is for what? Double derivative, okay, or the second order derivative. This is what your given thing, and this is what your first order derivative, so multiply it, and this is your the given thing. Now multiply with y. You will have, see that a m square e mx, here it must be m, okay, mx plus b n square plus b nx. Now try to see a m square. Do we have another a m square e mx? Yes, as you can see over here, so it must be m, okay, so this and this will be cancelled. Now what about b? So as you can see, b n square, one is here with minus sign, one is here plus sign, okay, so far so good. Now a m, okay, now a let me just, okay, so okay, a m n, so we are having now a m n e power n m x, okay, so this will be m, okay, so this will cancel this term and this will cancel this term, so you only left with nothing, every term is cancelled. So you prove that the given expression or the given, with the given y or function, the term or the expression becomes 0, okay, after putting the corresponding or the respective values, the term or the expression becomes 0, okay. I hope that it is clear. Okay, okay, so we have to stop here. So these are the 1 to 14th problem, okay, and we will do the remaining problem in the next session, okay. So we have to stop here. So why? Because as our time is over, so we have to go now. So I hope that you understood 1 to 14th problem of this exercise 5.7. so that's it from my side in today's session. So we will be back soon in the next upcoming session with the remaining problems and the remaining theory of this chapter, continuity and differentiability. So thank you all.